Hey guys, this is Pavan. Uh, Welcome to the video, and today we will talk about Euler's number or exponential or E, or you might have heard this exponential constant 2.7182. We'll talk about that, and don't mind about all these things. This is all jugaad during the lockdown. I'm not getting a whiteboard, so I thought why not to start with this, and we can learn, right? So आज हम देखते हैं what is this number E and how has it come, क्या जरूरत थी E की, और ऐसा क्या है मतलब कि हम हर जगह एक्सपोनेंशियल नंबर देखते हैं log base E, right? E to the power x, E to the power y, or whatever. E appears innumerable times in mathematics, right? So what is the number, what is the importance? Let's see. So I have a problem statement, and we will try to solve that problem, and then we will see where we are going to, and if we can derive this number E from there, right? So the problem statement is, you have 1 rupee in your bank account, and the bank pays you interest 100% a year, correct? Compound interest. What would be the amount at the end of 1 year? This is the problem statement. I repeat, you have 1 rupee in your bank account, the rate of interest is 100%, and the bank pays you 100% interest once a year. What would be your amount at the end of 1 year? Correct? So this is the basic formula of compound interest. We have already seen that during our school days. जब भी ये रहता हो 7th, 8th, 9th, I don't know. This is the basic compound interest formula. What is your amount when you have principal amount available with you, the rate of interest, the frequency of interest payment, the time period. So we have t equal to 1. We'll only talk about t equal to 1. Correct. Now let's see what it is. So intuitively you can say, right, at the end of 1 year 1 will become 2 if the rate of interest is 100%. Perfectly fine, no problem in that. आपका 1 रुपया 2 रुपया बन जाएगा अगर रेट ऑफ इंटरेस्ट 100% इन ईयर है और बैंक आपको साल के अंत में 100% इंटरेस्ट क्रेडिट कर देता है. तो लेट्स ट्वीक दिस प्रॉब्लम अ बिट. इंस्टेड ऑफ सेइंग कि बैंक आपको साल में एक बार इंटरेस्ट देता है, व्हाट इफ बैंक स्टार्ट गिविंग यू इंटरेस्ट 6 monthly, same interest rate. Your interest rate is 100% in a year, but bank say I'll pay you 50% in 6 months. Now what will happen? Will it be 1 rupee become 1 rupee will become 2 rupee? No, it will be more than that. Why? Basic formula, compound interest. Your n is equal to 2, t is still equal to 1. We are only talking about t equal to 1. Your n will become 2. Rate of interest is same. Principal is same. What will be the number? So let's see. I'll suggest you take out your calculator, do the calculation in parallel, or you have Excel sheet or basic calculator, mobile calculator, anything will work. But just take out your calculator and do it yourself. It will be better for you to understand and to understand this basic concept you will never forget in your life. तो हम देख रहे हैं n equal to 2 पे क्या होता है. So your amount will be equal to 1 plus 1 by 2 to the power 2. This comes out to be 2.25, right? Now this is for n equal to 2. What if I say that I pay interest per month, right? That is also a possibility. Interest payment is per month. Then your compounding will be 12 times in a year. This will become 1 plus 1 by 12 to the power 12, correct? Which will be more than this number for sure. So I have done few calculation already to make this concept easy without spending much time on the calculation part. I have taken n equal to these values 1, 2, 10, 100 and so on. Already done the calculation, but I suggest you do it at your end, just to be very clear, and memorize this thing for your whole life. You will never forget, I guarantee. What if n equal to 10? So logically what I'm saying is I'm paying you interest 10 times in a year. Interest rate would be 100 by 10. So 10% interest I'll pay you 10 times in a year. So n equal to 10, your amount will become 2.59, right? This is equal to 2.59. Just notice that for n equal to 1, our amount was getting doubled. I just tweaked the statement. I said I'll pay you 6 monthly. Amount became 2.25. I further tweaked it. I say I'll pay you 10 times. In 6 monthly, I'm paying twice, 2 times, n equal to 2. I'm saying I'll pay you 10 times. This is further increased to 2.59, correct? What if I keep on increasing the number n? Where will it end? Will this become infinite? Your 1 rupee will become infinite. If you compound your interest, let's say once a month, so 12 times in a year, this will further increase. What if you say once a week, right? So there are 52 weeks in a year, n equal to 52, 1 plus 1 upon 52 to the power 52. This will further increase. What if I keep on increasing n? Is this going to end up somewhere or what will happen? That is what we are more interested to know about. So I have just calculated these values. I have put n equal to 100, right? So I'm getting value 2.7048. I'll suggest you also do it in parallel. I have taken n equal to 1000, right? So this will be 1 plus 1 upon 1000 to the power 1000. Your amount will become 2.69. I'm writing it again. This is for n equal to 2. This is for n equal to 10. I'm saying n equal to 100. Amount is 2.7048. I'll say n equal to 1000. Amount is 2.7169. I'll say n equal to 10,000, or let's say 1 lakh, 100,000. Amount is equal to 2.7182. Very important thing to notice, when you are increasing n initially from 1 you made it 2, amount became 2 to 2.25. When you further increased it, this became 2.59. You keep on increasing it. This is 2.70497169. This increment is getting slowed. I made n equal to 1 lakh. So this formula will become 1 plus 1 upon 1 lakh to the power 1 lakh. This amount, this is 2.7182, became 2.7182. Keep on increasing and this number is not increasing to that extent जैसे वो पहले increase हो रहा था. What is happening here is, and notice this number. Do you see? Do you recognize this number? Okay, this number is the initial 4 digits of E. Correct? You further increase this number, instead of 1 lakh, make it 10 lakh, 100 lakh, or whatever big number you want, bigger than this. You will get this number 2.7182. Your further digits will keep on changing, right? So, कहाँ जा रहा है ये सब कुछ? What is happening here? Let's see. Right from the beginning, फिर से एक बार देखते हैं हमने क्या क्या किया. Our problem statement was, what if you have 1 rupee in your bank account and the rate of interest is 100% in a year, what would be your final amount at the end of 1 year, right? इस क्वेश्चन को हमने ट्वीक किया है on frequency of interest payment. If the frequency of interest payment is once in a year, your amount is different. If it is twice, your amount is different. If if I keep on increasing the frequency, your amount is different, right? And this amount will keep on increasing, maybe at a very slower growth rate from here on, if you keep on increasing this number, but this won't have any end. And I can say if my n tends to infinity, what would be my amount? This will become p 1 plus 1 by n, where n is tending to infinity, to the power n, right? My p is 1, so I'm not going to write it further. This will become 1 plus something like, if n equal to infinity, this will become 1 plus 1 upon infinity to the power infinity, right? But infinity is undefined, so we'll write it like that. N tends to infinity, 1 plus 1 by n to the power n. This number, can you calculate it? Accurately you cannot, because there is nothing called infinity. You can increase the number forever. You put 100,000, I'll put 100,000 plus 1. You put 10,100,000, 100 times 100,000, 10 to the power 10, I'll just keep on increasing 1. So this has no end. So that is why it has been defined as a limiting number. That is the basic definition of limit, that when you can't define a number accurately, you have to see the tendency of the limit where it is going to. I have seen the tendency of this limit where it is going to. At least I have seen it for first 4 digits. You keep on increasing this number. This first 4 digits are going to be same. I have already calculated. You also calculated your end. This will remain same. So I have seen the tendency of at least this limit, that this can be defined as 2.7182, and further that number will change. At some point the fifth digit will become fixed. At some point of n, your 6, 7, 8 further digits will get fixed, and the further digits from there will keep on changing. That is the basic definition of exponential, right? So what does that mean practically? If you have rate of interest as 100%, the maximum return you can get will be equal to E, right? Irrespective of your frequency of interest payment. You keep on increasing n, the maximum number would be E, right? This formula you already know. In 12th or 11th class we see that in limits, that this limit is equal to E. तब तो हम याद कर लेते हैं, लेकिन हमें पता नहीं होता शायद कई लोगों को, एटलीस्ट मुझे नहीं पता था जब मैं लिमिट्स वगैरह 11th 12th में पढ़ता था, कि from where this number is coming from, right? So but this is the basic derivation of E. I hope you have understood this. And these are some of the further things about E. This is a value up to 5 digits, so we have derived up to 4 digits. You can keep on increasing n at your leisure time and see. I suggest you to spend some, half an hour, 1 hour on this concept, so that you won't ever forget this thing in your whole life. These are further things. E to the power x का series ये होता है, right? You can also you can also calculate the number of E from this series. So put x equal to 1, you will start getting e to the power 1. You just have to add this infinite series. Like if you add some 10 digits, you will end up in getting at least this number. If you add further 20 digits, you will have some more accuracy, right? You already know E is a irrational number. It does not have any terminal value. So this does not terminate. You keep on calculating. This will keep going on. अभी तक I think with our power of supercomputers and all, we have calculated up to trillion digits, more than trillion digits of E. You just keep on calculating. See, just this is an infinite series, and also positive infinite series. There is no negative number which is getting cancelled. तो ये आप बढ़ाते जाओ, ये बढ़ता जाएगा जहां तक आप बढ़ा सकते हो. इट डिपेंड्स ऑन योर कंप्यूटिंग पावर, नॉट ऑन द टेंडेंसी ऑफ ई, राइट? So that is why it is also called as limiting in the term of limits we can define E as this, which we already derived there. ग्राफ ऐसा होता है एक्सपोनेंशियल का. दिस इज नथिंग बट e to the power x, which is like 2 to the power 7182 something something to the power x. Since we cannot write this number completely, we call it as e. That is why the symbol is important, and this is all about e. So I hope you now understand what this exponential constant is, and you have a good grasp on after this video you know exactly what is e, and you have a good grasp on how to use this number, from where it has got derived, and who derived it. Very not very important, but still good to know. This person called you must have already seen Euler's number. बोलते हैं हम इसको. Euler नहीं होता pronunciation. This is pronounced as Euler. Oil, right? Euler. We write it as EULER. So this person, he was working on this problem which we just discussed, and then he arrived at this conclusion that the maximum return would be E, and this is how this constant came into picture. So this is the person behind this, and very important constant. You will find it in whole of the mathematics, even in finance, economics. This if you Google this term continuous compounding, this is the continuous compounding. So Google this term, think more about that. There, this number plays a very important role. Exponential series, this plays an important role in how the viruses and bacteria multiply, how the radioactive elements decay. So this constant is very important to know, and I hope now you have all